This is a NEET 2019 question in thermal properties of matter. The problem is this. A deep rectangular pond of surface area containing water is located in a region where the outside air temperature is steady at a value of minus 26 degrees centigrade. Let me try to draw what he is saying so that it will become easy for you to understand. This is the surface of a lake, deep rectangular pond. This is a rectangular pond. I am drawing a rectangular pond for your convenience. This rectangular pond has a surface area A containing water of density rho, specific heat S, located in a region where the outside temperature is minus 26 degrees centigrade. And the thickness of the frozen ice, what is further said is, the thickness of the frozen ice layer in this pond is at a certain instant is x. He meant to say that this is all the formation of ice. I'm just assuming like this is all the formation of ice whose thickness is equal to x. From surface to this point it is x. So obvious that at the bottom the temperature is 0 degrees centigrade. Taking the thermal conductivity of the ice as K, so for this material, take the thermal conductivity as K, specific latent heat is L. What is the rate of increase in the thickness of the ice layer at that instant will be? So with respect to time, by how much the ice layer will be formed, dx by dt is how much? That's what the given question is, right? So because the outside temperature is very small, very less, minus 26, ice will be keep on forming. How does it form with respect to time? How much is formed with respect to time is being asked, right? Because the outside temperature is very cold. Because of cold, this surface will be keep on freezing. He is asking how much it freezes per second. Dx by dt is that much. So the first thing that what I can write is the rate of flow of heat as per the coefficient of thermal conductivity or thermal conductivity concept. We can say the rate of flow of the heat dq by dt equal to K A, temperature difference between them, and inversely proportional to the length of the conductor. Here in the place of dq, I can write dq basing on as it is given in terms of the latent heat. Latent heat is defined as amount of heat required to convert unit mass of substance from one state to other at constant temperature. Therefore, dq equal to ml. But it is not given in terms of the L, it is given in terms of the density. So density can be written like mass by volume. As area given, I can write further volume as area into length, as this the area of the surface multiplied by the length is x. So in the place of mass, I can write density into area of cross section into thickness of the layer, right? So in the dq equal to ml, I have to write, but in the place of m, density, area, and x has to be written. Density, area into x has to be written, right? That's the meaning of the dq, right? Rather, it is dq. I will write density area into thickness as I will write as dx as it's a small value. So I can write density area into dx. That's dq. So dq equal to ml as I told you. Let us substitute the dq equal to ml in this equation. Then what happens? That's right. dq by dt means dq can be written density area into dx. If it is q, I could have written density area into x by dt. dq by dt. This is only mass. dq means mass into latent heat has to be written as per the definition of latent heat. Into latent heat. L is the latent heat given for you in the problem. Equal to K area. Difference in the temperature is, the highest temperature is 0. Increase in temperature. Minus lower temperature is minus 26 as it is given. Right? By L is the thickness of that layer. That's nothing but equal to X. Now both the sides area will cancel. Rho L dx by dt, where rho is density, L is the latent heat, equal to K, 0 minus of minus is plus 26 by X. You want dx by dt is how much? So 26K by X. This also go to the denominator by rho and by L. That's the answer for the problem, right? Option C is the answer for the problem. That's how we solve this problem. So to solve this problem, actually, though it looks like a lengthy problem, it's depending on core definition of the coefficient thermal conductivity, rate of flow of the heat. It is a simple rate of flow of heat in a solid conductor. Ice is considered like a solid conductor, directly proportional to area, directly proportional difference between temperature, inversely proportional to length. Proportionality is a constant called coefficient of thermal conductivity. I have just substituted the data. Only thing is I have converted this dq into the other format as ml, as latent heat is given for you, and that m I have again converted in terms of density and area and thickness. That's how we have to solve the problem. Thank you for watching.